Hello again, everybody, and welcome to the webinar, ABCs of UAVs, hosted by Skycatch and Bramco. Thank you for joining this morning. My name is Jackie Gilbo, Marketing Director here at Skycatch, and I'll be hosting this webinar along with my partner in crime, Joe Kiesel, representing Bramco. So first, just some housekeeping items. We left some time for Q&A at the end, but feel free to type your questions at any point during the webinar in the chat box. We'll be monitoring that throughout the webinar, and we'll also be sending out a recording by email. So if you missed anything, no worries, you'll get a copy of the full presentation. So before I introduce our main presenter, I'd like to quickly go over the agenda here today. To understand why and how UAVs are worth using, it's important to revisit the workflow of traditional surveying and how UAVs can help take your productivity to the next level. So we'll be going over that, traditional surveying, and the future of mapping. We'll recommend some considerations for choosing the right UAV specific to your needs and some regulations to keep in mind when you're ready for your UAV program to take off. So before I get started, I introduced myself, but I wanted to launch a quick poll here to get to know you. So what best describes your industry? And I'll give it a moment before we move on. So it looks like majority of people voted, not surprising, 40% in construction, as we have a construction professional as our main presenter today, and a lot of drone service providers, some mining. Looks good. Thank you for voting. So I'd like to introduce our main speaker today, Joe Kiesel, who truly has experience in all sides of the construction industry. He has a mastery in both the consulting and hands-on experience as from many years as a surveyor, and now serves as a geo-positioning lead at Bramco Machinery. Bramco provides the products and support for the full life cycle of construction projects, from pre-construction to as-built, measurement, and data capture. They offer a variety of other solutions besides Skycatch, so I'd encourage you to check them out. So without further ado, Joe, take it away.
Thank you, Jackie. So just to kind of give you guys my background, I think maybe to build some credibility. I've been in the construction industry for a long time. My father has his own business, so I grew up in the heavy machinery industry, operating machinery since about 8 years old, and then that piqued an interest in surveying. So in the early 2000s, went to school for surveying. Did that, worked for a civil engineering and design company for about 8 years. And then in the mid 2000s got my license in Indiana and then later on in Kentucky. So I am licensed in a couple states. Been a GPS user for a long time as well, since about the early 2000s, running GPS only and then integrating into the GNSS we have today. But really just had a high desire and interest in technology. And in the last 10 years, been in the machine control industry, again with my family having a background in excavation. And I was doing a lot of the layout and survey work for them. I really realized a lot of jobs were changing, and machine control technology, integration with technology was coming. So I convinced my father and uncle to get into machine control, started building models for them, doing that kind of work. And then that evolved into where I saw a lot of need for customers in our area that I did work for, wanting to get machine control. And then with working with TopCon, they got me involved and partnered up with Brandeis, who at the time was getting involved in machine control. And so just kind of evolved from being an end user to the dealer side, where I've sold machine control, done install support for 4 or 5 years, and now I've gotten back into the survey side, where now I'm selling survey technology services and really training, helping customers figure out that, you know, how these technologies can be utilized in their fields. So just trying to learn from experience and impart that knowledge on others. And as Jackie mentioned, you know, one of the things at Brandeis and Power, what we've really tried to do, they're you know, both Komatsu heavy machinery companies, and they realize technology is here and that we need to understand it, and we need to be able to train and provide opportunities for customers to utilize it. So we've developed a strong team of guys and that really know the technology, that live it, and then we're out there training customers. And so we do offer that full A to Z as far as services, support. Whether you want to have us build models, we'll do that. Or if you want to learn how to build models, we'll train you on how to do models for your machine control. You want to learn how to utilize UAVs, you know, we'll take you out and show you best practices and so on and so forth. So that's just kind of some of my background, just to kind of give you guys, I'm not just a somebody come up and say, hey, here's what I like. I've utilized these technologies, and I stand firm behind them and believe in them. So let's go ahead and get started here today. Jack, if you could, it's not rolling forward here. Can you make sure I've got access?
Oh.
Yeah, it's not letting me go to the next slide. There we go. So again, depending what your background is, whether you're, as I said, you're in the construction, you're mining, whichever, you know, the geospatial industry, which basically encompasses everything now. Typically, we would be concerned with surveying industry or engineering, but that really kind of covers everybody now. Everybody's using some sort of positioning technology, from the agricultural to aerospace. Everybody's using some sort of positioning technology. But as I said, my background, one of the things I take to heart when I went to college for surveying, our professors trained us up, you know, in rudimentary systems, dumpy levels, theodolites, just chains, just doing that, and evolved us into a digital total station or digital theodolite, and then we got into data collectors and so on. And so, but again, in this industry, we're seeing all these rapid changes in technology. What works best, and it really depends on what are you doing and what are you after, what's your time constraints. But again, you know, GPS is kind of the mainstream now for a lot of positioning technology, and it works great for many cases, but it has its places. Terrestrial laser scanners have become more prevalent and really taken off tremendously in the last few years with building information models, and that building information model really becoming the whole site, not just inside the walls. Robotic total stations, again, workforce manpower is low, so companies are looking for ways, how can I, you know, gain my efficiency, and when I can't find the manpower to work. So then again, that's where UAVs or mobile mapping technologies are really becoming more prevalent. UAVs are allowing us to do large amounts of workflow, collect information, and still have that accuracy that we need, or very close to it. And the other thing is it's creating safe operator environments. These are kind of some numbers. So as I said, I worked in the civil engineering and surveying industry for a while. When I last left that company I worked with, I was survey manager. And when we would typically send out a two-man crew, if we would send out a two-man, you know, traditional crew, we could cover, like it says, roughly 40 to 60 acres a day. We'd probably build $1,200 to $1,500 a day on that. We had fairly high accuracy because we're using total station, checking our measurements, you know, pretty consistently, running level loops. But again, that's very time consuming. And if any of you guys have ever done construction layout, if you're doing a traditional method with tape, theodolite, or even total station, it does take quite a bit of time. There's a lot of work and rework. When GPS came out, became more mainstream, we were using that for horizontal layout, traditional topo. We could cover more ground, typically with one man. We charge a little bit more, but we did realize, you know, hey, there was a little bit of accuracy decrease because of GPS. You know, we knew we could be roughly within a 10, sometimes better. But one of the biggest challenges we ran into was as job sites started utilizing more technology, more machine control, or, you know, obviously cell phones are great, but people are on their cell phones all the time. Job sites somewhat became unsafe. So just being able to take our crew or our people off the site, or remote off the site where they weren't right in the paths of machinery or areas like that was key. Other things we often ran into was often we just too little information was collected. You know, we knew that we needed this area. We sent a crew out and they went out and collected, and crap, we didn't get enough information due to time constraints where I needed to get to another job. Or not getting enough of the big picture. So that's where, you know, with UAVs and having that orthophoto, really see what's going on. One of the key things I see a lot of guys doing with UAVs when they're doing surveys, they're calling in their utility locates, like making sure they're done right before they fly. And so when they fly, they have the utility locates on that orthophoto. So that really makes a difference when they're trying to do their design and they've got a timestamp. Hey, here's what was going on. So we're talking with our customers and just kind of running numbers ourselves. We typically see that we save our clients roughly about 40% over traditional methods. And then nowadays when jobs are getting tight, yeah, it's where, you know, your time is money. It comes down to that, and really trying to help you be more efficient. So I want to go through a little bit of information. You know, some folks say, what does UAV mean? What is UAS? Or, you know, often the term drones used. As it says, we typically like to use the word UAV, that unmanned aerial vehicle. You know, drone is kind of that military term. It's kind of reserved for them for that. You know, everybody wants to say drone, but really it's kind of that was coined by the military and so on and so forth. I kind of relate to people, you know, we are in the heavy machine industry, and a lot of people say, I need a Bobcat. Well, they don't need a Bobcat, they need a skid steer, but being Bobcat's one of the prevalent brands, you know, people often call them that. Same thing with someone who wants a drone, whether it's a fixed wing or a rotocopter. Hey, I need a drone. Well, what type of UAV do you want? Um, and as going into the next step there, so fixed wing, typically your fixed wing UAVs, there's quite a few different companies out there. Sensify is probably one of the more prevalent ones. They've got their EB. Those drones are used to cover pretty much larger areas, 500 plus acres. Usually those systems are a hand launch, or sometimes they need some sort of launching strip, and they usually take a larger area to land. I know some of the technologies are getting better. I believe there's a manufacturer out there now that has a vertical takeoff and landing, which is pretty slick. But that's going to be your fixed wing side. On the rotocopter, they've become very prevalent just because of the agility, being able to get in tight spaces, that vertical takeoff and landing. And the other aspect is inspections. Rotocopters, we do a lot of inspections with that, or just progress photos, or just videography, and that's one of the benefits of a rotocopter. So when I was looking into UAVs a couple years ago, so I've been actually flying for a little over 2 years now, got involved with it, and actually I mentored with a gentleman that had done the large commercial photogrammetry with the large plane. I kind of asked him why he got out of that and got on UAVs. He said the biggest thing, he just got tired of flying, just getting older. He wanted to be more mobile. But he said one of the big challenges was it's very costly to do that. He said just small areas may cost up to $10,000 or more. So I don't have a lot of experience in the big UAV flights. Some of you guys may. But again, it's larger sets of data, takes more time to process. The UAV data collection we utilize, the structure and motion photogrammetry, we're able to go to small sites from, say you got a half-acre site with some piles, or you got, 100, 200 acres. You can do all that with the structure and motion and achieve good results. So what we're doing in that process, we're utilizing the tablet and the Skycatch mapping software and really creating that site. As you can see from those images, those are a couple sites we've flown and just saying, hey, I want this area at the top right one, I think it's roughly a 40 acre, set up a flight, preset all the settings, what height that I want, what's my overlap, so that's one of the things when you look at photogrammetry, what's my terrain look like? Usually the steeper the terrain or the more differences in elevations, I'll increase my overlaps, front lap and side lap, and I can explain that more in detail to any of you that want to know more about that. But it really set all those parameters, and once you fly, I mean, really the flying portion is pretty simple because it's full autonomous. So the drone's going to take off, and after the flight, that data is either going to be processed either on your PC if you're using, traditional methods. You may use ground control, but there's different softwares out there for that. You may use the cloud site like our Skycatch data hub, or you may be using some sort of system like what we use is our Edge One base station, which personally I think is one of the key things about the Skycatch system is that I can take the SD card directly out of my drone when I'm done, plug it into the Edge One base station, and with the tablet set my parameters, hit process, and I can walk away, and that project, depending on the number of pictures, will be processed in an amount of time. One other technology I wanted to kind of bring up too, because sometimes people ask, what's the difference between structure, motion, and LiDAR? LiDAR is just light detecting and ranging. It's a laser type technology. It's using reflectivity. LiDAR is great. It is a very big investment for folks if they want to get into it. Most of your terrestrial scanners, whether you're running Topcon or Trimble or Leica, they have some sort of terrestrial scanner where it's sitting there spinning, collecting millions of points a second to pick up that information. They're great for all types of applications, but they do have their place. Again, it's time consuming. They do produce highly accurate three-dimensional measurements as well. There's many types of data returns you can get from LiDAR. You can use it in conjunction with different processes to get those. As I said, though, it's a pretty hefty investment. There's a company locally here in the Midwest that's developing a mobile UAV LiDAR attachment, roughly running around 60 to 65,000. So it's a pretty hefty sensor, and then you've got to have a UAV strong enough to pull that. So most UAV applications are going to be anywhere from $80,000 to $200,000 to get involved in that investment. So what we're going to see though in the near future is that as LiDAR scanners get better, one of the biggest drives of that's the automotive industry with smart cars. A lot of vehicles have some sort of LiDAR scanner in them or some sort of that in there. And I think industry, from what I was at a seminar recently, talked about currently these scanners are set up for like 50-meter distances, and industry is pushing for 300. So as we see with anything with the automotive industry, if they do that, we're going to see dramatic decreases in probably price for LiDAR. Just to give you another example too, when I fly one of these 25-acre sites with structure in motion, I'll probably, after some manipulation, probably have around 3 million points, and then I'll probably even resample that down because I really don't need all that detail. But that's pretty close to where the raw would be. A LiDAR project for that same would be closer probably to 1 billion, just to give you some ideas on differences in data sets there. Advantage of LiDAR, whether it's mobile, UAV, or terrestrial, it can be used at night. Can penetrate water areas, some water areas, and penetrate dense green areas. So that's what we always ask. What are you wanting to do? What are your results? We have some customers that want to fly an area for a quarry, and they want to get down to the base ground, but they've got a lot of trees. So that would probably be a better LiDAR situation. Our structure for motion photogrammetry, it's going to be a lower cost investment on bare ground, on hard surfaces, rock, gravel, sand. These hard surfaces, it's going to give you pretty good accurate data, similar to the tolerances of LiDAR. The biggest difference, LiDAR can give you multiple returns. As I said, structure for motion, it's giving you that first return. So whatever that camera sees first, that's what it's going to give you a return that's going to create on your surface. So data collection methods. So prior to utilizing Skycatch, when I first started, I was using ground control networks. So what I would do on a site, again, with the gentleman that I mentored with and kind of got the UAV background, he said, I would recommend 500-foot spacing on ground control. Now, some of you are already doing it. You may have other numbers, but he said if you want to keep to half a tenth or less, 500 foot is perfect. He said if you go 1,000 foot, you're going to have about a tenth or more. And so this site that I've got kind of picture was 120 acres. I had 93 control points out there. Some of them were a little tighter because of some of the elevation changes, but it was very time consuming. But I utilized Agisoft for my photo stitching. I would go through each individual picture that a control point was in and match those up. Some of those photos would appear 20 times, some of those control points would appear 20 times in there, so you can see that it's very time consuming, but it worked. With PPK, the post-process kinematic, so that's what we're utilizing with the Skycatch. Technically, no ground control is required. So with this project, I flew it again later on after I started utilizing the Skycatch. What I would do is I would just set ground checkpoints. Again, surveyor background, I don't ever want to believe 100% my technology is working perfect. I always like to have a fail-safe. So on this one, I think I went out and put about, when I flew this again, about 8 to 10 checkpoints, and running through it, we still achieved that same accuracy. So on the PPK system, it's kind of, if you've worked in the surveying industry, it's kind of similar to what we used to do with static post-process. You're going to have a base station, which here is our Edge 1 base station. It is a, it will collect static data. It'll also do the processing there. And then we've got our tablet with our software and our drone. The drone also has, or the UAV also has the GNSS. It has the traditional, it's a Matrice 100 airframe, but it also has a more integrated GNSS with it as well. So we post-process the data, geotag them. That way we can really check to make sure we have it correct. The third method of UAV collection is RTK. RTK is really becoming more and more prevalent, just as it did with GPS years ago. It works fairly well. The biggest challenge we have is if there's some sort of communication breakdown between the base and the UAV. If that happens, you lose radio, then the photos aren't being geotagged, you have to start again. As technology gets better, that'll become more mainstream, I think, but currently, kind of our fail-safe, we refer to PPK. So we have different types of deliverables available from our data collection process. We're going to get an orthophoto, which is GeoTIFF, geo-referenced. We're going to get the OBJ, the object file, the 3D mesh. We can create DXF contour lines from it. We're going to get a PDF of either the ortho or the surface model. You're going to generate a point cloud. What's nice about the portal, our Skycatch portal, when you upload the data there, they'll process it and we can download it in 4 various settings from 400 points per square meter down to 25 points per square meter. We're also going to get the digital surface model and the digital train models. So where can you use the UAV technology? Basically, I tell folks you can use it about anywhere. The key thing, though, being you need to know what's going on in surroundings. So as one of the things I'll talk about later is becoming licensed, but you need to inspect what's going on in your areas. One of the things the FAA, they're really becoming more prevalent in helping us as UAV users to figure out where and when we could fly. So LANC, low altitude authorization notification capabilities, has been developed and implemented here in the last few months. It's really that collaboration between FFA and end users and industry to figure out where can we fly, when can we fly, utilizing their partners, different airspace partners and apps to do that. So worst case, you're going to contact a local air tower and say, hey, I'm flying in this area, is there any issue? And you get authorization from them. So again, what is required to fly? If you plan on using the UAV for commercial use, you need to obtain your Part 107 UAS pilot's license. I say it's a fairly simple exam. If you study for it, and truly study, you'll pass it. If you just try to take it off the seat of your pants, you're not going to. But it's something you have to take every 2 years. I just retook mine in April, and I believe that the retake was like 45 questions. So it's a good test. Like I say, it really gets you aware of what's going on with that as well. And then what can I use this for? Really, the sky's the limit, pun intended. Currently, we use it, as I said earlier, for progress pictures. We have some customers that, hey, I want you to go up and I want you to take monthly pictures to show me where my project is coming along. We do ortho photos. We do site inspections, topographic surveys. We've also done some videos for presentation while machines are running or while job sites running for customers for their media display for their websites. We use it for demonstrations, but there's many more uses. As I say, UAV is a great tool. You could probably come up with more uses. I know our law enforcement and EMA are using it for a lot of different sources. There's different payloads you can get for drones or UAVs, infrared, just different types of cameras. So a ton of uses. So I'm going to turn it back over to Jackie here.
Thank you, Joe. So that was a lot of great information, and just a reminder to the group, we'll be sending this webinar back to you, so if you missed anything, don't worry. You'll have a copy. So just one last poll here. Actually, I'm going to skip that because there's quite a lot of questions already. So just some final considerations before purchase for their evaluation process. We have some questions for you to consider here. First and foremost, it's important to know who will be using the output of your data and what the requirements are. As Joe mentioned earlier, there are several types of mapping solutions out there, and the density of the data will be a huge consideration for this, for the right tools. Conversely, if your customer is only looking for marketing fly-through videos, it might not be worth the investment into a precision UAV solution. The second point here, when you're considering how many times you'll fly per month, per year, other software solutions charge by the data set. And to be the most cost effective, it's important to be realistic with the amounts of data you'll be gathering. Our customers have seen the best results when they fly daily and use this in their morning BIM coordination meetings. They collaborate more efficiently, spot issues before they become costly mistakes, and be able to track centimeter level progress daily. But just to note, this isn't an upsell for us in our software solution because we actually have unlimited uploads per project. So lastly, time to data. If you're mapping a site once per year, perhaps the data in near real time isn't a compelling criteria, but for users that have sites that are measuring stockpiles or doing work verification, it's easy to get in disputes when there's a long lag time in between the completion of work and the final check. So for instance, one of our customers, Joe, would you mind advancing for me? I think you have controls. Thank you. One of our customers is Ora Minerals. They have mining operations all over South America and added flying the high precision package to their survey arsenal and saved over $300,000 per year in billing errors. So as Joe mentioned earlier, it's just easier to fly the entire site and capture more data than necessary, kind of the worrying that you haven't caught enough when you do it manually with other systems. So the high precision package truly incorporates everything you need for this mapping from capture. Sorry, would you mind advancing one more slide? From capture to analysis, all in one industrial kit. So the cloud software solution that we offer allows you to do markup, measurements, overlays, and share with unlimited users per project. But the most exciting piece is the Edge One, which you see here on the bottom right on the tripod. And this is what Ora Minerals was able to get the data back so quickly because the Edge One allows you to process your flight data on site without actually needing any network or cellular connectivity. So Joe mentioned earlier that you fly with the drone, take out the SD card, process in the Edge, and a lot of our customers actually fly, throw that in the back of their truck, and by the time they're on the way to the office or from the site or the mine, your data will be, depending on the density you need, the data will be ready. So 2D maps, 3D point clouds in about 30 minutes. And you could expect around 5 centimeter level accuracy for this, and especially without GCPs. So you can stay directly out of the pit or off the side of a stockpile while heavy machinery is working around you to keep your crew safe while you're mapping. So now if you want to advance one more slide, we have some time for some Q&A. So let's look at these questions. And now is a good time to ask any questions if you have any more. So Joe, this is a good question for you. Are volume calculations, progress tracking, and earthworks management something that can be done within an hour of flying on a mission?
Absolutely, depending on the size of the project, as you said as well. So those, I mentioned 25 acre because we've got a few customers that's kind of their typical subdivision size of the project. So just to give you an idea with the Edge one, so we flew 25 acres at about 200 feet, and it took roughly 10 minutes to do the flight. We took the SD card output in the Edge, and in 45 minutes after processing at standard, which would give us roughly, I believe the point density is 4 points per square meter, which was plenty dense for what we needed, was about 1 hour from start to finish. So that was everything. And then what we did, that customer there, he's an Agisoft user, so we gave him the deliverables in both the point cloud, the digital surface model TIFF, and then the ortho TIFF, and he just plugged them in and did his number crunching from there, and was happy with the results.
Thanks, Joe.
I see one of the questions too is what file types do you support and what outside software? Okay, so the file types we talked about earlier there, as I mentioned in the earlier slide. I can go back to that. As far as outside software, it really depends on what you're using. I know that, as I mentioned, Agisoft, AgTech works very well with it. Civil 3D, you know, if any of you guys are Civil 3D users, they're taking the point clouds and a lot of these. We work with the TopCon software, the Magnet Office software. It takes a lot of those. For softwares that don't handle point clouds, we actually utilize another third-party software, Virtual Server. Some of you guys may be familiar with it. We're actually a reseller of that as well. We found that works. I like the tools in it, being able to bring the point cloud with digital surface model in, create break lines, create surface from that, and then all those exports typically DXF. But many softwares can. Those are the ones that I know of. I'm sure probably TBC, Triple Business Center, they have some capabilities with that. And again, I know a lot of folks are Civil 3D users. I'm pretty confident Bentley as well has some good module importing to that as well. Let's see, what else do we have? Another question, do we offer local coordinate system support? Absolutely. So depending on you know, what technology you use, with the Edge One, what we do is we load up a CSV file. So this is actually most of the projects that I do personally for customers are all local coordinate systems. Very few are on state plane grids. And so what we'll do is we'll go out and we'll get their calibration file, and I'll create a CSV file that basically has that calibration data, the geodetic and the local. And when we process, so the Edge will process everything in UTM, and the last step is it translates, moves that information over to the local coordinate system. So, and that's done there with the Edge, and the website will do it as well. You can create your localization file, load it up, and you can translate that stuff to local coordinate systems.
Thanks, Joe. So there's a question about the price. I would contact Joe after. He's going to have his contact information out, up on the screen with his sales guy. So I would definitely reach out to them to get a quote, and he'll be able to tailor that.
There's a question there talking about does the software have, the Skycatch have software that extracts break lines such as tow, crest lines? Okay. So with the Data Hub portal, there are things coming down the line. They're working towards that. As I said, currently what I do is I utilize Virtual Server for that. So the Edge One, the Skycatch, doesn't have all those fancy tools just yet, but they are coming shortly. It's something that they're implementing here, I believe, later this year. So like I say, currently we're utilizing Virtual Server for that. Another question. Let's see here. We'll take a couple more questions here because I don't want to keep you guys all day.
Sure.
How do you tie the data into the site coordinate system? So if you're using a localized coordinate system, that's what I was talking about. We'll create a CSV file that's actually put on the SD card that when you process the data in the Edge One base station or system that's there, it will translate it towards the end. Same with the website, you'll load up your coordinate system on there in a format that it'll read it, and at the end it translates that information to that. Best is maybe to see an example of that. If you'd like to learn more, we can show you a detailed example of that. Does Skycatch provide near vertical photogrammetry capabilities for high-res photos for geotech and geological mapping? So one of the things that's nice about the Edge One base station is it takes that data and it's going to resample it to basically get it ready for what you're going to want deliverable. If you want full resolution photogrammetry, we recommend uploading everything to the website. So the Skycatch web portal processes in full resolution for all that. So if you're going to need that, then you need to upload to the Skycatch portal.
Perfect. So we are over time. If you want to advance, and we can give them the contact information.
Absolutely. Yep. So let me get back to the end here.
Perfect. So if you want to follow us on social media and hear about those future upcoming announcements and stay connected to us, this is the Skycatch information. And on the next slide is how to get in touch with Bramco for a quote, services, support, training, all of the above. So thank you everybody for joining ABCs of UAVs with Skycatch and Bramco, and we'll keep in touch. Thank you.
Thank you guys.